Snake is a very simple game where you have to collect the maximum amount of apples without colliding into walls or your own body. Due to this simplicity, it was first created as an arcade game 48 years ago, but personally, I think the best version was the Nokia games. Too many good memories for me. So yeah, the concept has been around for some time and enjoyed by many, but how many Snake players have been created? So, the plan is fairly simple. We want to create a Snake AI that is better than me. It shouldn't be that hard, right? Well, as you will see, it took me a little bit more effort than what I expected. But let's go back to the beginning. This all started with a single Google search, which led me to realize that you could actually play Snake on your browser. Then I spent too much time playing it, until I gave up on my fingers and my reaction time. I was clearly not good enough. But this story, of course, doesn't end like this. I was furious, and the only thing I wanted was to get that score higher than what I was able to achieve by just playing. So I wondered, how can I create an AI that plays Snake for me? That way I could get unreachable scores that I would never get. Maybe I could use the browser game and make an AI play with some JavaScript code. Okay, so the only reasonable option left is to recreate the whole game from scratch in Pygame. Yep, that's it. The perfect choice. Board. Snake. Snake movement. Smooth movement. That was quick. Not for me though. Anyway, let's look at the problem itself and what we actually want to do. We have a board, but actually what we're looking at is more like this. We have the head in one position and the apple in another. And yeah, we also have the body of the snake. And if you have seen any Snake AI videos, you probably know what's coming. Pathfinding! But if you don't know what a pathfinding algorithm is, it's pretty simple. In our case, we use A*. Let's see an example of how it works. We start in the initial position, and we know which position we want to reach. So, using that information, for each empty cell that surrounds our actual position, we can calculate the following values. The C is the amount of moves needed to reach that position. Meanwhile, H is an estimate of the distance from the position to the end. Then, you keep evaluating the position with the least combined cost until we reach the final position. Okay, that was a lot. Let's actually look at how this performs on our Snake game. Whoa, wait a second. What happened? Oh, this is embarrassing. Let me explain. There are two problems. The way I coded the pathfinding, if there is no possible solution, the game just crashes. But the snake didn't eat the apple yet. Well, it actually did. It just didn't update the screen, you see, because first the game calculations are done, and then the screen is printed. The only problem is that if you crash before you print, you end up with something like this. And yeah, technically this game of Snake is not lost, but the pathfinding is only calculated when the apple is generated. So, we can modify the algorithm to improve the performance. Or, we can take a new approach. Deep Q learning. Yeah. Wait, what? You actually don't know what Deep Q learning is? Really? That makes two of us. But don't worry. I'll try to explain what I kinda did to get an actual agent working. Anyway, let's first note that DeepQ learning is a reinforcement learning algorithm, which means that the way we're making the machine learn is not by looking at examples. Instead, we are going to define how good an action is, giving rewards to some of them. Using these throughout the game can give us the information that this position is better than this position. But which rewards are you even talking about? In our case, we define this set of values. So, if the snake eats an apple, it will get a 10-point reward, but if it dies, it will get a -50. So, using these guidelines, the algorithm will learn to play by trying to get the maximum score. Although, actually, it's quite the opposite. It really learns by taking random actions and observing what the outcome is. This way, it can associate which moves or behavior leads to better outcomes and scores. That is called exploration. When it thinks that it has learned enough, it goes into exploitation mode, where it actually picks the best move almost every time. So that is all, right? Right? No, of course not. This is DeepQ learning. You have to throw in a deep neural network. And that's it, I think. Oh yeah, a snake. Let's get this running. Wait. Let's add graphics for the neural network. Much better. The input layer, yeah, I forgot. So, the snake only has access to this parameter. It doesn't really see the board. What it sees is this. Am I going up, down? Is there a danger going right, left? And where the apple is placed. To the left, to the right, upward, downwards, you get it. Now, let's go and see how well it does on the snake game. Okay, so after running this for about 2 more hours, this was the best run we could get. which gets us a high score of 49. It's a bit sad when A-Star was able to reach 54, but this took way too long. Oh, bonus clip, some smaller maps, yeah. If you really want me to give this another try, you can tell me in the comments. I have a few ideas on how this could be improved. Subscribe!